Okay, welcome back. So again, we're still in chapter 1. We're moving on to section 1.3, which is number systems. And today's learning objectives is to interpret Roman and Arabic numbers and convert values between the two systems. And we're also going to review identifying scientific notations and converting large and small numbers to scientific notation. So number systems. Again, we use Arabic system, so we use the metric system in pharmacy. But in certain instances, for prescription purposes, we'll use the Roman numeral system. And in prescriptions, we'll use the Roman numerals because, again, since they're representations of letters, it's harder for them to be changed in the value. For example, a 6 can be converted into an 8, or 3 can be converted into an 8. So it's easier to manipulate the prescription if you want to forge it. Rather than with using Roman numerals, it's harder to change, for example, a V, or a C to a D, an M to an L, or an L to an M, vice versa, whatever it might be. So it's harder to change that value, and therefore change the prescription of the medication. So a Roman numeral this is a system using letters to represent quantities or amounts, either using lowercase letters or capital letters. If we look at table 1.5, we can compare our Roman system to the Arabic system. So SS will signify half. So if you ever see a quantity of VSS, that would be meaning V stands for 5, and again SS is half, so that would be 5.5. So you're probably giving 5.5 of a medication. An I, capital I, or a lowercase I, or an I, lowercase I with the line in between will signify 1. A V, a 5, X, a 10, L, a 50, C, a 100, D, a 500, M, 1000. Okay, so little asterisk in the lower letter C. If you have a double C, that means it's a cubic centimeter. So just keep that in mind. So the following prescription is received in the pharmacy. How many tablets are in a daily dose and how many tablets are to be dispensed? So you have a prescription metformin 850 milligrams. The 6 says I tab daily with food, dispense C tablets. So determine the dose. So what does the lowercase I signify? 1. So that means that this is equal to, the dose will be 1 tablet. So you're taking 1 tablet daily with food. Next is determine the quantity to dispense. So C, we said C signifies 100. So C tablets is equal to 100 tablets. So you will be dispensing 100 tablets. And some guidelines to interpret Roman numerals. So whenever there's a number repeated or a smaller number followed a larger number, the values are added. So in this case, lowercase I or uppercase I, so you have 1 and 1, so 1 plus 1 is 2. LVII, so you have a larger value and then a smaller and then a smaller, so that means you're just adding. So L is a 50, V is 5, II is 1 plus 1, so 50 plus 5 plus 1 plus 1 is equal to 57. C represents 100, X 10, and then you have 3 I's, so that's 111. So 100 plus 10 plus 1 plus 1 plus 1 equals 113, and so forth. So when a small number comes before a larger number, subtract the smaller values. So in this case, we have a smaller number I letter and then a larger value V. So So you have 5, which represents the V, minus 1 because the I is before the V. IX, so 10 minus 1 is 9. CD, so D is 500 and C is 100. So you're going to subtract 500 minus 100, which is equal to 400. So the next one is numerals are never repeated more than 3 times in the sequence. So you have I 3. You won't put I to get a 4. You'll just have to do the subtraction, which is the V, 5, minus the 1I. You have 10, 10, 10, that's 30. If you want 40, you can't put another X here. You would have to do the subtraction value of 50 minus 10 will give you the 40. So when a smaller number comes between two large numbers, subtract the smaller number from the number that follows, okay? So you wouldn't subtract 10 minus 1 here. You would get the 10 and then you would subtract the next 10 minus 1. So you have the first 10 here, then you have an I-10. Those are the ones you're going to subtract. So 10 minus 1 is 9, plus 10 is 19. Here you have 10 IV. So again, I is smaller than 10 and V. It's between two bigger numbers. So you're going to subtract the 5 and the 1. You're not going to subtract 10 minus 1. Okay? So 5 minus 1 is 4. And then plus 10 equals 14. So make sure you keep those guidelines in mind. Then we have the Arabic number system. So this is the normal system with it that we use, numbers 1 through 9. And of course we have 0. So it represents whole numbers are the left of the decimal point, whereas fractions are to the right. So remember what we learned in the previous section, that anything before the decimal is a fraction in groups of tenths, okay? So the position for the numbers to the right of the decimal point are called the decimal places. Guidelines to interpret Arabic numbers. So the numbers to the left of the decimal point represent, again, whole numbers, part of the fraction. If there are numbers, no numbers to the left of the decimal point, places 0 to the left of the decimal point. Again, this is the called a leading zero, and we want that in pharmacy so we don't get any confusions. If whole numbers parts are different, whichever has the largest whole number part has the higher value. So 8 is greater than 6, so 8 is greater. 20 is greater than 14, and 3 is greater than 0. If the whole number parts are identical, including if both are 0, look at the numerals to the right of the decimal point, starting with the 10th value, the first one, and proceeding to the right. If the tenths are different, the fraction with the greatest tenth has the largest value. So again, looking at the tenths place, so 4 and 3, 4 is greater. 4 and 3, 4 is greater. Okay. When the tenths are identical, a number with a decimal fraction that is greater in hundreds has the greatest value. So again, if our tenths are the same, 1 and 1, then we're going to look at the next value. If it's greater than so 7 is greater than 5, so that would 17th would be our greatest value. 3 and 3, and then we have 5 and 0, so 5 would be greater. 6, 6, then we have 6 and 4, so 6 again will be greater than 4. If the hundreds are identical, then the value is determined by the thousands and so on. So you continue down the line. So 1 and 1 is the same, 2 and 2 is the same, so 5 and 4, 5 is greater, so that's a greater value. The total values of numbers is the sum of the different parts. So 467.43 represents 400, 60 is a 6 tenths, 7 represents 7 ones, 4 represents 4 tenths, and then the 3 place represents 3 hundredths. To say this number as 467, and again, and is the decimal point, 43 hundredths, okay, would be your representation in letters. Scientific notation. So the scientific notation is a method used to write numbers that have very large or very small numerical value. Because of spaces issues as well as readability, it is not practical to write out the number that have a large number of zeros. So in this case, so if we have 6,500, that's not very much large numbers of zeros, but we can set it up as a scientific notation. So we'll count the values. So we have 1, 2, 3, and then that's where we're going to put the decimal. There should always be a whole number, right? So there's 3 places to the left, so that will give us 6.5 times the 10 represented with an exponent of 3, because those are the 3 spaces that we used. Then here we have 1, 2, 3, 4, 5, and that's where we're going to put our decimal. So 1.2 times 10 to the exponent of 5, because we moved our decimal 5 spaces to the left. Now going to the right, 0.109. So again, we want just one whole number. We don't want more than 1. So in this case, we just moved our decimal 1 space to the right. So that means just an exponent of 1. But since we're moving to the right, that exponent will be a negative exponent. Okay? Oops. Go back. What happened? So our answer would be 1.09. And again, we have to write all the digits that have an actual value that is not 0. Okay? So 1.09 times 10 to the negative 1, because we moved 1 space to the right. Looking at the last one, let's say 0 point, and then we're moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces to the right. So that means that our answer again would be a whole number 4 decimal point 9 times 10 to the exponent of negative 11. Okay, so that's how we write exponents. So give the equivalent Arabic number for I give you the answer. X Roman numeral. So what does the X signify? A 10. Okay. Give the equivalent Roman numeral for a 17 Arabic number. So again, we have a 17. We have, we want to separate this. So then we have a 10 plus 7. So 10, again, we know it's X. Then 7, we want to add. We don't want to use 111. Remember, we can't use more than 3 of the same letter. So that means we're going to have to separate this 7 to a 5 and a 2, right? 5 plus 2 is 7. So then our number would be 10, then a V, because V represents 5, and then 1 would represent our 2 other numbers. Okay? So then the last one says write the 0.000329 number using significant notations. So we're going to count our number of decimal spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we move our decimal places to 9 places to the right. Again, since it's to the right, that means it's going to be a negative exponent. So now we're going to write our number as 3.29 times 10 to the negative 9. Okay? And our next one will be, see you in the next video on estimates. And again, if you guys need additional help, please go to the Q&A discussions and mark your questions there, or again, send me a private email and we can discuss further if you need additional help. Thank you and see you in the next video.